there's a lot of really mysterious things about this airplane. When they discovered it, first off, they found it in a Gotha factory. Most people, and especially the Air Force and the Luftwaffe, called it the Horten 229.
Germany built a stealth plane 70 years ago, and what it was really designed for was hidden, not from the enemy, from you. The aircraft exists. It is sitting in a museum right now. Most people walk past it in under 30 seconds. What they do not know is that the documents recovered alongside it, locked in a facility safe, classified on the spot, and buried for decades, described a mission so dark that the engineers who built this plane were never permitted to discuss it publicly.
Doing gliders in the 1930s to producing the world's first all-wing turbojet-powered aircraft.
This is what was inside those documents, and this is why it was hidden: the flying wing. Here is where the story really begins, not in a war room, not on a factory floor, but on a grassy hillside in 1920s Germany, where two brothers watch a wooden glider arc through the air and ask a question that no serious engineer in the world is asking yet. Walter and Reimar Horten grow up building and flying gliders during the brief window when unpowered flight is the only kind Germany is legally permitted to operate.
The opportunity to work on something like this with history behind it, and that's what made it a little bit special.
What matters is what the brothers notice every single time they study a conventional aircraft. It is always the same thing. On every airplane without exception, the world is built the same way. Long body down the middle, wings attached to the sides, a tail sticking out the back, fins pointing upward, military fighters, civilian transports, experimental prototypes. They all follow the same blueprint without anyone stopping to ask why. The design is accepted as fixed. It is taught as correct. Nobody questions it. The Horten brothers question it. What most people never realize is that all of those extra parts are actively fighting the air. The fuselage, the tail, the fins. Every surface that is not a wing is generating drag. They bleed speed. They force engines to burn more fuel just to maintain altitude. The brothers work through the aerodynamics and arrive at an uncomfortable conclusion.
The Horten brothers were not a factory. They were not industry people.
In any conventional aircraft, a substantial portion of engine power is not going toward flight at all. It is being spent pushing non-lifting surfaces through the atmosphere. That is structural waste baked into every plane ever designed. So they ask the question nobody else will ask out loud. What if you got rid of everything except the wing? No fuselage, no tail, no fins cutting into the airstream. One single graceful curved surface generating lift across its entire span, with the pilot, the fuel, and the payload all housed inside the wing structure itself. The aerodynamic efficiency would be unlike anything flying. Less drag means less fuel burned, which means you can fly farther and faster on the same engine output as a conventional aircraft. Not by a small margin, by a factor significant enough to change the entire strategic calculation of what an aircraft can reach and how long it can stay there. Here is the catch. It has never been made to work on a real aircraft. The brothers build scale models from cheap plywood and wood glue and test them on the same hills where they learn to fly. The results are startling. These strange crescent-shaped aircraft fly smoother.
Germany was going to gain air superiority as if he and his brother Reimar designed a flying wing twin-engine fighter.
And stay airborne longer than conventional designs of the same weight. The lift-to-drag numbers they record are better than anything in the published literature on conventional aircraft of the same era. They are not tinkering. They are proving a theorem with every test flight. But converting a backyard proof of concept into a combat aircraft requires funding, materials, and engineering resources. Two brothers with a garage workshop simply do not have. For years, they keep building, keep testing, keep getting turned away. Nobody in the German military establishment wants to hear it. The aircraft they are trying to build seems almost willfully strange. What nobody yet understands, including the brothers, is that strangeness is precisely what Germany is about to need, and the purpose this aircraft will eventually be assigned will have nothing to do with what its designers originally imagined: the impossible demand. By 1943, Germany is losing the war badly and losing it fast. Allied bombers arrive over German cities in waves, burning factories, destroying fuel supplies, and killing pilots at a rate the Luftwaffe cannot replace. Hermann Göring, commanding Germany's entire air force, is running out of options and out of time. So Göring does something that shocks every engineer in the country. He announces a hard specification and dares anyone to meet it. He calls it the 3x1000 program. The requirements are almost offensively simple. Design a combat aircraft capable of carrying 1,000 kilograms of payload, flying 1,000 kilometers at a speed of 1,000 kilometers per hour. The engineers go quiet, then they do the math. Then they tell him it is impossible. Contemporary fighters barely crack 700 kilometers per hour in a full-power dive. Heavy bombers cruise at around 400. Jet engines exist and they are faster. But jet engines consume fuel at such an aggressive rate that any jet aircraft fast enough to hit 1,000 kilometers per hour burns through its fuel load long before covering 1,000 kilometers of distance. The numbers do not close on any configuration anyone tries. Messerschmitt says no. Junkers says no. The whole program looks like the specification of a man who has confused ambition with physics. Then the Horten brothers look at the requirements and see something everyone else has missed. Their flying wing has a fraction of the aerodynamic drag of any conventional design. That one fact changes the entire fuel equation. Less drag at speed means dramatically lower fuel burn. Lower fuel burn means the range target is suddenly achievable on a fuel load that would strand a conventional jet well short of the finish line. Every time the brothers run the numbers, the result is the same. A jet-powered flying wing is the only design on the planet that can hit all three requirements simultaneously. Not by pushing harder against physics, but by having less physics to push against. They draft the proposal, call it the HO229, and send it in. Göring could have dismissed it. He could have filed it and moved on. Instead, he calls the brothers in and gives them everything they asked for. Materials, engineers, top priority access across the entire German production chain. For the first time in their careers, the funding has no ceiling. And the aircraft they are about to build will not just meet Göring's three numbers. It will do something no one officially authorized. Something the documents locked inside the facility safes will reveal to American intelligence officers who walked through the doors in the spring of 1945. Before this story is over, you will understand exactly what was in those documents and why the soldiers who found them were not permitted to discuss what they had read. Subscribe now and hit the bell. What was in that safe is the part of this story that stayed classified the longest. The ghost plane. Here is the revelation, and it is not the speed. The HO229 is not primarily fast. It is invisible. Reimar Horten has spent years studying British radar. His conclusion, stated plainly in post-war accounts, is this: any aircraft built of conventional metallic materials has already lost the radar war before it leaves the runway. Britain's chain home network transmits radio waves outward and reads the reflections that return when those waves strike solid objects. Metal reflects radio waves almost perfectly. Every aluminum and steel aircraft in the sky lights up on a radar screen like a fire in a dark room. The material of construction, Reimar decides, is not a secondary consideration. It is the primary one. Wood does not reflect radio waves the way metal does. The waves scatter, they attenuate, or they pass through entirely. An aircraft built of laminated wood composite returns almost no radar echo. A vague smear on a screen, or nothing at all. This is not improvisation. This is a design decision, but Reimar goes further than the material itself. The adhesive binding the layered plywood panels of the HO229's wing skin is formulated with coal dust and charcoal particles. And this is Reimar's specific contribution, his own insight documented in the facility records. When Northrop Grumman scientists obtain surviving samples in 2009 and subject them to electromagnetic testing, they find that the carbon particles are absorbing incoming radar energy and converting it into trace heat, not reflecting it, not scattering it, consuming it. This is not a side effect of cheap wartime materials. It is deliberate physics engineered into the composite structure of the aircraft in 1944. It is, in every functional sense, radar-absorbent material, 4 decades before the concept is publicly acknowledged to exist. When Allied engineers pull the HO-229 apart after capture, their first assumption is practical. Germany ran short on metal, so they used wood. That is partly true. It is also precisely the conclusion the design was built to invite. The 2009 replica test settles the question definitively. Against radar systems equivalent to Britain's chain home network in the 1940s, the HO-229 replica produces a signature indistinguishable from a large bird or weather noise on the screen. A conventional bomber of the same era appears from 200 kilometers away, giving radar operators and fighter controllers 90 minutes of warning. The HO-229 appears with less than 8 minutes remaining. Think about what 8 minutes actually means. England's entire air defense architecture in 1944, the fighter squadrons, the anti-aircraft batteries, the civil defense network, is built on the assumption that radar will give controllers enough time to respond. 8 minutes is not enough time to scramble fighters. It is barely enough time to sound an alarm. The HO-229 does not reduce the warning window, it eliminates it. And the stealth itself is not the weapon. It is the delivery mechanism. The question, the one that was locked in the facility safe, is what the payload bay was sized and engineered to carry. The hidden purpose. The payload specification of the HO-229 is 1,000 kilograms. That number is not inherited from Goering's program requirements by coincidence. It matches the projected weight of a specific weapon that Nazi Germany is quietly developing in parallel with the aircraft program itself. Germany never builds a functional nuclear bomb. The resource requirements, the physics, the infrastructure, and the timeline all work against it. But a dirty bomb operates on an entirely different and far more achievable principle. And it may be more strategically effective than a nuclear device for certain objectives. A dirty bomb combines conventional high explosives with radioactive material harvested from nuclear reactor testing. It does not require fission. The explosion itself may be modest in immediate destructive yield. What it leaves behind is the actual weapon. Radioactive particles dispersed across a contamination zone, poisoning soil and groundwater at concentrations that render entire city districts uninhabitable for decades. The objective is not to destroy structures. It is to make the ground permanently lethal and force an evacuation that never ends. Cities recover from bombs. They do not recover from contamination at that scale. The HO-229 is built to carry exactly this. Fast enough that radar stations have 8 minutes of warning or less. Small enough on radar to register as atmospheric noise, carrying a payload precisely calibrated to the weapon's documented weight. The documents recovered from the facility are explicit on all three specifications: the weight, the payload bay dimensions, the material composition of the delivery platform, and the target assignments. All documented together in the same intelligence file. The aircraft and the weapon are designed in coordination, not in parallel isolation. What most people never understand is that the planners are not thinking in terms of a single aircraft delivering a single weapon. They are thinking in terms of formations, multiple HO-229s arriving simultaneously across multiple targets, each one invisible to the radar network, each one carrying a payload designed not for a single strike, but for the permanent denial of the target area. You do not need to win every engagement if you can permanently remove the ground from the equation. And the engineers do not stop at the HO-229. Among the blueprints found locked in the facility safes is a design called the HO-18, not a derivative. A complete redesign for a different strategic mission entirely. 3 times the size of the HO-229. 6 jet engines. Fuel load calculated for a fully transatlantic crossing. The aerodynamic analysis places a fully loaded, radar-invisible aircraft within operational striking distance of the eastern seaboard of the United States. The geometry is complete. The range figures are worked out. The target list is documented. London. Allied Army positions advancing through Belgium and France, New York, Washington, D.C. This is what was in the facility safe. This is what the soldiers who forced open that hangar door were not cleared to fully understand. And this is what stayed classified for decades after the war ended. The underground empire. Here is the problem Germany is confronting by late 1944. Allied bombing has made above-ground aircraft manufacturing functionally impossible. Factories are burning, supply chains are fractured. The rail network that moves raw materials to assembly plants is being cut faster than it can be repaired. The Luftwaffe is losing aircraft faster than assembly lines can replace them. The HO-229 cannot matter if there is no facility left standing to produce it at scale. The solution the Nazi high command commits to is underground production on a scale that is genuinely difficult to comprehend. In the Owl Mountains of what is now southwestern Poland, a construction project called Project Ries, Project Giant, is already underway. Slave laborers drawn from the Gross-Rosen concentration camp system are driven into the mountains and forced to excavate. Tens of thousands of workers are used. A devastating number die from exhaustion, deliberate starvation, cave-ins, and direct killing by the guards. The mountain tunnels are built on human bones. What those workers are forced to create is not a shelter. It is a full industrial manufacturing complex buried inside solid granite. Main corridors run for kilometers, wide enough for heavy overhead crane systems. Rail lines are laid underground, so raw materials arrive, and finished components depart without appearing at the surface. The deepest sections sit under more than 50 meters of rock. No Allied bomb in 1944 or 1945 can reach production lines buried at that depth. The plan? Move HO-229 production entirely, underground, and build them by the hundreds. There is a test pilot named Erwin Ziller who has been assigned to the program around this time. Years of experimental test work, composure under pressure, the ability to read a new aircraft in real time and make the right call. The program has chosen him specifically because the HO-229 is unlike anything the Luftwaffe has ever put in the air. He is preparing for the certification flights. The tunnel factories are almost ready. The timetable is almost closed. The Allies reach Friedrichsroda in March 1945 before any of it is finished. The entire program, the aircraft, the tunnels, the weapon coordination, all of it, runs out of time by weeks, possibly less. The crash and the discovery. On February 18, 1945, Erwin Ziller takes the second HO-229 prototype to 800 meters above Oranienburg airfield. The aircraft is performing exactly as designed, smooth, responsive, almost eerily quiet. Its jet engines buried inside the wing. Structure rather than hanging exposed off the leading edge. Ziller has flown radical aircraft before. He has brought machines back that other pilots would not have attempted. He is the right person for this aircraft. Then the right engine dies. The cause is never definitively established. Mechanical failure is the first possibility. But documentary evidence also suggests that carbon monoxide from the failing engine enters the cockpit before Ziller can execute emergency procedures, incapacitating him rather than presenting him with a problem he can work through. What is certain is the physics. A flying wing without a conventional tail has no mechanism to counteract asymmetric thrust once one engine loses power. The geometry that gives the HO-229 its extraordinary efficiency in balanced flight becomes a death trap the moment that balance breaks. The aircraft enters a flat spin from which there is no recovery sequence. Ziller does not survive. The prototype burns on impact. 3 weeks later, on March 14, 1945, soldiers of the United States Army's 3rd Armored Division force open the doors of a sealed hangar in Friedrichsroda, Germany. Inside, on a wheeled trolley surrounded by abandoned tools and work orders left exactly where the workers dropped them, is the 3rd HO-229 prototype, days from completion. The final welds not yet closed, the cockpit instrumentation not yet calibrated. It never gets those days. Every component, every blueprint, every document is cataloged, crated, and shipped to the United States under Operation Paperclip. The HO-229 ends up in Smithsonian storage for decades, classified and out of public view. The full picture of what it was designed to do was uncomfortable knowledge, and it stayed that way for a long time. The legacy that changed aviation. The engineers who received the HO-229 blueprints and materials analysis do not file them away. They go to work. Jack Northrop had been developing flying wing designs independently in California. His YB-49 shares the same core geometry. That parallel thread closes quickly once the German data arrives. American Aerospace Research absorbs the full Horten documentation and begins applying it to a new strategic requirement. The Cold War is beginning. The Soviet air defense network is expanding. The United States needs a bomber that can penetrate those defenses without warning. The Northrop Grumman B-2 Spirit enters service with the United States Air Force in 1997. It is the direct technological descendant of the HO-229 in every meaningful sense. Same fundamental geometry. No fuselage, no tail, no vertical fins. One continuous blended wing surface. It flies 2 crew members and a full weapons load across intercontinental distances without being detected, and the air defense network on the receiving end does not see it until munitions are already on their way. On contemporary radar, its cross-section is approximately the size of a large bird. A single B-2 costs approximately $2 billion. The United States builds 21 of them. The 2009 Northrop Grumman replica test closes the historical loop. Against radar equivalent to Britain's chain home network in the 1940s, the HO-229 replica does not merely reduce its signature, it effectively disappears into background noise. The carbon-based absorption, the blended geometry that scatters rather than reflects, the aerodynamic integration of the radar absorbent structure into the airframe itself. None of it originates in post-war American research, starting from a blank page. It is transferred in crates leaving Friedrich Roda in March 1945, in blueprints cataloged by intelligence officers who did not fully understand what they were holding. The F-117. Nighthawk and the B-2 Spirit are both downstream of the same chain of understanding that begins with 2 brothers in a German garage calculating drag coefficients on cheap paper with a slide rule. The math that makes a $2 billion stealth bomber invisible to radar was first worked out in the 1930s. Everything that came after was refinement. The HO-229 is on display today at the Udvar Hazy Center in Chantilly, Virginia, the Smithsonian's annex facility, sitting in open storage alongside other recovered aircraft of the Second World War. No dramatic placard explains what it was designed to carry. No sign describes the target list found in the facility's safes. It represents the single most consequential weapons technology transfer in the history of aviation, and most people walk past it in under 30 seconds without stopping. Here is the question worth sitting with. If the Project Reese tunnels had been completed 6 months earlier, and HO-229 production had started at scale in 1944, do you think the radar networks protecting England could have held? Drop your answer in the comments. That debate is always worth reading. Subscribe and hit the bell. There is more coming, and it hits just as hard.